All right. Hi, everyone. Dr. J here. And in this video, we're going to talk about sea level and tidal datums. Tides are really fascinating, just a really fascinating thing to learn about. And you can see a picture here which shows the effect of tides. So tides is basically sea level going up and down over time in coastal areas. And everywhere else too, but in particular, we see it at coastal areas because we've got the land to reference to. Here's an example of some boats that are in the low tide right now. And once the tide comes in, those boats will start floating and they'll get all the way back up to the top of those piers that you see there. So tides are pretty amazing things, and we need to understand something about tides in order to understand how we use datums, vertical datums in the ocean and along coastlines. So sea level is the average height of the ocean surface relative to the land, but that's constantly changing. It's constantly changing due to the tides, of course, and then also due to waves and atmospheric pressure and other effects. But the tides are a big, probably the most important impact in coastal areas. And these are caused by the effect of gravity from other planetary bodies, mostly the moon and sun, on the Earth. So this is a diagram, kind of just, well, maybe not the most helpful diagram, but essentially you have gravitational forces from the moon and the sun on the Earth, as well as centrifugal forces because the Earth is rotating. And you also have kind of local effects of configuration of the coastline, bottom topography, that's bathymetry, and the local just topography and geometry of the water depth with the coastline. Those are going to have a big effect on the local tide. But overall, on a global scale, it really is the moon and sun that are driving Earth's tides. And this happens because as the Earth rotates under the moon and the sun, then the side of the Earth which is closest to those planetary bodies tends to experience a high tide, and then more water gets pulled towards those bodies because of their gravitational pull. And then there's less water on the perpendicular sides of the Earth relative to those bodies. And it gets, of course, a little bit complicated, and this is a very simple diagram to start us out, but you can think about a tide as being just the water level going up and down. So if you were to take a ruler to the beach, stick it in the sand, and wait for several hours, for let's say a 24-hour period, you would see the tide going up and down. And it will go up and down at least once in a 24-hour period, and sometimes twice. Those are diurnal and semi-diurnal tides, respectively. And that causes, can cause tidal currents, things like that. The tidal period is what is the time period between those two peaks in the tidal range? And that, again, can be once or twice per day. And then the average of that tide over time is going to be your sea level, your mean sea level. Now it's a little bit tricky here, and I'm not quite showing you everything. I think I've got another time series that I'll show in a little bit, which is showing the longer tidal range. The tides actually change not just um, during the day, but over longer time periods as well. So there are bigger tides at certain times of the year when the Earth and the moon and the sun get closer together because of their orbits. And so there's more complexity in the tides than just a daily cycle up and down. And so that leads to some differences in how we'll define the different tidal datums. So let's talk about tidal datums. We need to have a vertical datum for use in coastal areas. It's a base reference elevation from which local water levels are measured. So these are going to be local datums, and we're going to use we can use various types of tides to use as a datum. You see here these letters, MLW, MHW. Those are going to refer to different tides, which I'll define in a second. And they're going to be basically, you're going to make measurements at a specific location over time. That's going to define these levels, mean lower water, mean high water, mean sea level. And we're going to use those as our datums. And there, we can relate these to our land reference frames, our vertical datums, by use of benchmarks. And so that's usually done for establishing a tidal datum at an area. The US nautical charts are going to be using a particular datum, which is called the mean lower low water. And again, I'll define that in just a second for tidal areas. And so that's one that you'll want to keep in mind is that if you're looking at a chart, it's going to be always using the mean lower low water tide. But let's go ahead and start defining what these things are. So as I mentioned, these are going to be standard elevations, going to be made by averaging tides over long periods of time, and they're going to provide that reference point. And you see different tides here relative to this tide staff. Tide staff is just like a ruler measuring the tides. But let's define a few terms first, because we'll need these terms in order to understand these datums. So the geoid, we've talked about the geoid before in this class. The geoid is based on the gravitational potential, or geopotential is another term that you might hear related to the geoid. Other types of vertical datums that you may have heard of or that we've talked about in the class are the ellipsoid, and then you could potentially use local datums such as tidal datums. But the geoid is going to be based on gravity, and of course, because the sea is liquid, it's going to be strongly affected by gravity as well. And so if you hear the term mean sea level, that's going to be related to this geoid term. So, excuse me, mean sea level is going to be a gravity-based term or related to the geoid. And there's some differences here from the geoid, which I'll define in just a minute. But that's going to be the kind of reference frame to keep in mind is the geoid. It's not the ellipsoid. Now, the National Tidal Datum Epoch is a 19-year period used to calculate tidal datums. Now, you might say, why 19 years? That seems kind of random. It's not. It's actually based on the longest tidal period that we have. So there's a 19, actually, I think it's 18.6 year cycle with the Earth, Moon, and Sun, which causes a 19-year period in the overall high and low tides in an overall tidal cycle. So you've got your daily tidal cycles, and then there's kind of seasonal tidal cycles that are related to the moon's trip around the Earth every month. And then you have your 19-year periods that are going to be your longest tidal time periods. The current National Tidal Datum Epoch is what is used to establish the tidal datums that are being used right now. All the data from 1983 to 2001 was used to calculate what the current National Tidal Datum Epoch is. And it is scheduled to be updated after 2026, we're almost to that point, to a datum that will include all the data from 2002 to 2020. So these things are updated over time. And this is going to account for the astronomical cycles. And then because there's sea level change, sea level fluctuations over time, we need to update every 19 years in order to get the latest data for that datum. I'm using data and datum. So just as a reminder, datum is what we're going to be, that's our reference line, our reference height that we're going to be relating our other heights to. Data is the measurements of height over time that we're going to be using to calculate the datum. Now let's look at some of our actual tidal datums. So now we've sort of got our data. We've collected data at a bunch of tide stations, maybe, and we're going to use that now to calculate our tidal datum. So what are the definitions for our tidal datum? So here's our different possible tide levels that we could use. We have mean high water, mean higher high water, and then the highest observed, mean low water, mean lower low water, and lowest observed, and then we have our mean tide level. And these are pretty self-explanatory. So you can see how the tide is changing through time. And again, as I said, there's this 18.6 year cycle that we also go through. So as the tides are changing through time, we can take the average, we could take the mean high water, mean low water. Really, it would just depend on what your application is, which one you would want to use. And as I mentioned, they're specific to particular locations because bathymetry and coastal geometry and topography impacts what the local tides are, as well as hydrodynamic processes, currents, things like that, that result from those bathymetry and coastlines. So let's look at some definitions here. We got mean sea level, and of course that's just the average of all the water levels over the NTDE over that time period. Also known as local mean sea level, right? Because local mean sea level, that's just the sea level average for that area. The mean lower low water, average of the lowest low tides, and that's what's used for nautical charts in the US, as I mentioned. So we're going to take our lower low tides if we have variations in those over time, and we're going to use that as our datum. That would be MLLW. Mean higher high water, that's going to be the mean of the higher high water heights. We've got mean high water, mean of all the high water heights. So every single, right? So if I back up here, we're just going to take the higher high tides as an average. We're going to average those together over our time period for that MHHW datum. And then, of course, we've got our mean low water, mean of all low water heights observed during the current NTDE. And then, of course, the mean tide level is just the halfway point. And we can calculate that in various ways, such as halfway between the MHW and the MLW. So that would be here. This is just our average tide over that time period. So any of these can be used as datums. The navigation charts are using the mean lower low water. And of course, why would you do that? Because then it's very easy to see, will you be able to navigate through a river without having to worry too much about if you're at a low tide or if you're at a high tide. Is there enough water in this coastal area or in this river, channel, estuary, whatever, that will allow you to navigate if you're a boat, right? So that mean lower low water is used for navigation. Now, I mentioned that there is a difference between the geoid and the and sea level, and that is related to what's called dynamic ocean topography. This is the difference between the time average sea surface and the geoid. Now, what kinds of applications are tidal datums used for? Well, we need to define, we need to provide safe travel for navigation. We need to use, boats need to be able to navigate in coastal areas. We might need to design coastal engineering structures. And if we were doing coastal engineering, maybe we were actually wanting to use the mean MHHW, the mean higher high water mark, as our tidal datum because we want to construct buildings that are not going to be flooded out in high tides. So here's just some different examples of how tidal datums really affect things like navigation. So we need to make sure that there's enough clearance between the mean high water level and the vertical clearance that we have under a bridge, let's say, or a cable crossing a water area. We need to be able to navigate above obstructions on the surface of the seafloor, whether that's a wreck of a ship or a rock, right? So these are all needing to be monitored and documented, and our tidal datums are going to be used to help us do that. All right, so let me just summarize up. Tidal datums provide the standard reference for understanding and measuring sea level and sea level changes through time, and this is going to be on local areas. There are local, small areas around a particular tidal station, and that's going to help for navigation. It's going to help for engineering. It's going to help for coastal development and the impacts of sea level change, managing the impacts of sea level change. They're essential for all of these kinds of activities. The NTDE, that's our National Tidal Datum Epoch, that allows us to average time periods over a long enough time period that we have, it allows us to average tides over a long enough time period that we're able to get a good sense of what is the total variation that could occur over that time period and get a good estimate of mean sea level during that time period as well. All right, so that's it for tidal datums, and I will see you in the next video.